In my last video tutorial, I have introduced you to the conditions of three turning points. Now in this session, we're going to use those three conditions in solving some of the maxima and minima problem. Let us go with question number 1. Find the points at which the following functions have a maximum and a minimum values. Also find the points of inflection if any. So here the question says that you need to find maximum and minimum values and point of inflection. Now one thing that you need to be clear is here the question is asking you to find maximum and minimum values, not maximum and minimum points. So there is difference between maximum and minimum values and maximum and minimum points. But here the question is specifically asking you to find just maximum and minimum values and inflection point if any. Now how we solve this kind of problem? So here you are given a function and the function is being expressed in terms of variable x. So first thing that you need to do is you need to check which condition of the three turning point the given function is satisfying. So for that one you need to check this condition, dy by dx equal to 0, and you need to see what is going to be the value of the second order derivative. If the second order derivative is greater than 0, which means if it is positive, the given function is going to be maximum. If it is less than 0, it's going to be minimum. Now as per this condition, we need to find the first order derivative. So I'll differentiate this one. Is going to be 3x squared plus 12x minus 15. And if I find second order derivative, it's going to be 6x plus 12. Now as per this condition, we need to equate this equal to 0. 3x squared plus 12x minus 15 is equal to 0. I can further simplify this equation by dividing both sides by 3. So I'll get x squared plus 4x minus 5 equal to 0. Now this is a quadratic equation, and I suppose all of you know how to solve quadratic equation. So after solving this quadratic equation, the x value that you're going to get is going to be, x value is going to be 1 and negative 5. So these are x values. Now next what we're going to do is we're going to see what kind of turning point do we have at these two x values. So therefore what I'm going to do is I'm going to take this x value and replace in this second order derivative. So at x equal to 1, let us see what is the value of the derivative, second order derivative. So I'll replace this x equal to 1 in this equation, and I'm going to get positive value which is greater than 0. So here second order derivative is greater than 0, which means at this value x, your turning point is going to be minimum point. Likewise, let us find what kind of turning point we will have at x equal to negative 5. So it's going to be 6 times negative 5 plus 12. So you're going to get negative 18, which is less than 0, meaning at this point your turning point is going to be maximum. It's going to be maximum. Now from these two, what we know is we know what kind of turning point your function is going to have. Now we're going to find maximum values and minimum values. So let us first find the minimum value. Here minimum value would mean the value of the y. So your value of the y, which is minimum value, is going to be, you replace 1 in the original equation and it's going to be when you simplify this one, you're going to get negative 3. Likewise you can find maximum value. Here maximum value would mean maximum value of y. So y value is going to be, what you can do is you can replace x value in the original equation. And you'll get one value, so that is going to be your maximum value. So this is how you solve maximum and minimum problem. So first thing that you need to do is you need to check which conditions among these three turning points the given function is satisfying. Then you find the maximum value. And if the question is asking you to find maximum point and minimum point, you have to just write write these x values and y values in coordinate form, and you need to write these x values and y values in coordinate form. So thank you.